In this video, we're going to demonstrate the difference between a virtualized list and a non-virtualized list. So a non-virtualized list loads all of the data that the list is populated with into the DOM. So it creates HTML elements for all of the rows in the list, even the rows that are not currently visible. A virtualized list, on the other hand, only creates DOM elements or HTML elements for a fraction of the data that is in memory. So you can see here we have two lists. The top list has been virtualized and the bottom list is not virtualized. So if I go back to my controls here and I look at the top list here, I can see that when I go to the list properties for the first list there, you can see that we've got the virtualization turned on, but here for the second list virtualization is turned off. Then what we have is a JavaScript function over here that's going to generate 2,000 rows of random data for the list. So let's click the button and there's the JavaScript is finished executing now. So we've just generated 2,000 rows of random data, and now we're going to populate the list. So first we'll populate the virtualized list. So we'll click the button and you'll notice that the list populates practically instantaneously. But in actual fact what's really happened is the list has only created HTML elements or DOM elements for a fraction of the 2,000 rows for the so-called page size, which in this case has been set to 50 rows. So when I scroll the list I can scroll, and then when I get to the end of my page I can go and get more data from the in-memory data that has been loaded into the list. So whenever I hit a page boundary I can go get more data. It's not an AJAX callback, it's just JavaScript code, so it's extremely quickly, but the amount of data that's in the list at any given point in time is limited to the page size. So now let's click the button to populate the non-virtualized list from the same JavaScript array of data. So I'll click the populate list now, and you can see there's a significant delay before the 2,000 rows are populated. So you can see now this list has all 2,000 rows in it, and it's consuming much more memory than this list over here. Now in this case we had 2,000 rows and there was a fairly significant delay, but as the list grows bigger and bigger the delay gets longer. So now let's go back here, for example, and change the number of random rows that we generate from 2,000 to say 100,000. So now we're going to be generating a significant amount of data. So we'll go there and click the button, and I'm going to say generate random data. So now our JavaScript is finished. We've just generated 100,000 rows of random data, and now when I click the populate list virtualized, you can see that it still happens extremely quickly. So this list has now been populated with 10,000 rows, but it's a virtualized list, so only 50 rows are being rendered at a time, and then when I hit a page boundary we go get the next page of data. So we're fetching the next page of data, and then if I go backwards I need to go and hit the previous page of data. So by using virtualization we minimize the amount of data that is kept in the DOM at any point in time. Although the list has all of the data in memory, it just hasn't been rendered. So now I'm not going to actually go ahead and press the populate non-virtualized list, because with 100,000 rows this would take a significant amount of time. So what you can see here is that using virtualization you can dramatically improve the performance of your list when working with a large number of rows, and also you can reduce the memory footprint that your list controls take, which is especially important on mobile devices. Thanks very much for watching.